Good morning. So, a very warm good morning to everybody. I am Professor THIRUMARAN, working as a professor in the Department of Physics, Annamalai University. I am very happy in meeting all of you here. And today, on behalf of my department and on behalf of my university, I am extremely happy in welcoming all of you for your enrollment as DD Physics, especially first year program. In the first year program, I am supposed to be take one of the core paper, that is electromagnetic theory. Very important paper, one of the important paper, because as you know all well, the electromagnetic theory is a very frontier one. Even you use cell phones, mobiles, all are emitting electromagnetic waves. You are well aware of it. And these electromagnetic waves, nothing but they are in the form of microwaves, radio waves. Even for satellite communication, we are using microwaves. So these are all completely belonging to electromagnetic theory. So electromagnetic theory, electromagnetic waves means very useful to in all sorts of in all aspects of life. It is inevitable. You can't avoid this the use of electromagnetics. It is found application wherever it is applicable there. Now let me go to the concept, the very important concept usually available in physics. As you all know, corpuscular theory, wave theory, electromagnetic theory, quantum theory. These four theories are very basic theories, still it is available. The corpuscular theory was formulated by Isaac Newton, one of the famous scientists for discovering for the three laws, first law, second law, third law. And the second, wave theory, this theory was formulated by Huygens. Next one is, that is the one of the core paper that we are going to see, electromagnetic theory, proposed by James Maxwell. Another one is called quantum theory, proposed by Max Planck. So all four theories are very important. As corpuscular theory and wave theory mainly reports about the nature of waves, because according to corpuscular theory, the waves, that is light particles, are propagating in the medium as in the form of very minute corpuscles called corpuscles, very minute particle. Therefore, even the theory is itself also called corpuscular theory. But it was completely refuted by Huygens. No, light is not propagated as not in the form of a minute particle. Instead of that, it is propagating as waves. Therefore, the theory is called wave theory. So there was a controversy between these two theories, that is corpuscular theory and wave theory. And finally, as science advanced, we later come to know that light waves neither possess corpuscular and wave theory. It is a dual nature. It possesses dual nature. Next one is the electromagnetic theory. Very important theory, because electricity, electric field, magnetic, as you know, magnetic field. So the electric field and magnetic field, the combination of electric and magnetic field in a single equation, a single theory called electromagnetic theory. So the credit goes to Maxwell. He combined all these electric field and magnetic field altogether and put it in a theory called electromagnetic theory. We know Einstein, famous for the equation E is equal to mc square. Why it is E is equal to mc square is so famous? Because E energy, m is mass, mass belongs to matter, because matter possesses mass. Therefore, the energy and matter is put into single equation. It means energy can be converted into mass and or matter can be converted into energy, vice versa. So that is why that equation was very famous. Similarly, even electromagnetic theory, James Maxwell put electric field and magnetic field in a singular equation, in a single equations. So that is why the electromagnetic theory was very famous. Not only that, we can explain all the phenomena of light, that is especially reflection, refraction, interference, diffraction, polarization, total internal reflection. So these are all you can easily explain with the help of electromagnetic theory. But however, the only drawback found in this electromagnetic theory is it could not explain the phenomenon of photoelectric effects. Even though despite all these merits, the only demerit found in this theory, electromagnetic theory, this theory, that is electromagnetic theory, could not explain the phenomenon of how this phenomenon of, that is photoelectric effect, taking place. This was rectified, another theory called quantum theory, that is proposed by Max Planck. So there is a separate paper, quantum physics and quantum mechanics. So we are concerned about only the electromagnetic theory. So this is proposed by Maxwell. James Maxwell formulated the electromagnetic theory. As I told earlier, he brought both electric and magnetic fields under one equations. He explained the light waves are electromagnetic waves, not only light. so many things that I will show later, all are belong to electromagnetic waves, that is called the electromagnetic spectrum. If you go through the electromagnetic spectrum, you can see that is visible as well as invisible contents. That means that it is the electromagnetic spectrum consisting of both visible contents as well as invisible contents. The visible contents extending between 4000 angstrom to 8000 angstrom unit. The remaining all are invisible, like infrared, ultraviolet, so many things, etc. A magnetic field is set up around a current carrying conductor, first noticed by a scientist called Weierstrass. Suppose a conductor which is carrying a current, the current is passing through the conductor. He noticed that a magnetic field is set up surrounding this current carrying conductor. And he also found that both magnetic and electric fields are acting perpendicular to each other. How can we understand both electric and magnetic fields are acting perpendicular to each other? If you go through the Ampere swimming rule, if you go through the Maxwell corkscrew rule, we can clearly understand that both magnetic and electric fields are acting perpendicular to each other. That is, magnetic field H, electric field E, both have magnitude and direction. As you know well, in physics, any quantity, any physical quantity having both magnitude and direction are called vectors. Therefore, we may call it as magnetic field vector, electric field vector. So, therefore, totally called field vector. So, in electromagnetic theory, if I say field vector means it indicates both electric field vector and a magnetic field vector. Normally, electric field vector is represented by capital E, E vector. Normally, the magnetic field vector is represented by mathematically H, capital H, H vector. Therefore, E and H. Therefore, using these three rules, that is Ampere swimming rule and Maxwell corkscrew rule, clearly establishing that both magnetic as well as electric fields, these two fields are acting perpendicular to each other. As magnetic and electric fields are perpendicular to each other, means for example, magnetic field is represented by x-axis and electric field is represented by y-axis. So, what about the resultant direction of z-axis? The resultant z-axis is neither electric nor magnetic, it will be electromagnetic. Okay? Once again I repeat it. Suppose if a magnetic field is represented by x-axis, if electric field is represented by y-axis, the resultant z direction will be neither electric nor magnetic, definitely it will be electromagnetic. Any waves propagating in this way generally called electromagnetic waves, because this is the resultant direction offered by both magnetic as well as electric field. In this resultant direction, that is the electromagnetic waves propagate. Simply I can say both field vector are vibrating, oscillating or vibrating right angles to each other. Because of this vibration, they produce oscillations. These oscillations produce disturbances. These disturbances traveling in a direction which is perpendicular to the magnetic field and the electric field. Such a resultant direction in which these disturbances are called electromagnetic, because the disturbances travel in the form of waves. Therefore, we may call it as it is electromagnetic waves. Normally, electromagnetic waves mainly two properties. What are the two properties? Electromagnetic waves carry no charge and electromagnetic waves travel with the velocity of light. The concept of electromagnetic is a general topic. If I say electromagnetic means it includes gamma ray, it may be UV, it may be IR, it may be microwaves, it may be X-rays, it may be radio waves, even the visible light emitted are all belonging to electromagnetic waves, because electromagnetic is a common word. Therefore, gamma rays, no charge, but travels velocity of light. UV rays, no charge. No charge means neither having positive charge nor having negative charge. Therefore, it is unaffected by both electric field and the magnetic field. So, all the 7 examples I have furnished here are all belonging to electromagnetic waves, completely chargeless, and also they are traveling with the velocity of c. You know the velocity of c? C is equal to capital C is equal to velocity of light. What is the velocity of light? You all know well. Yes, you are correct. 3 into 10 to the power of 8 plus 8, not minus 8. 3 into 10 to the power of 8 meter per second. That is the velocity of light. So far, this is the maximum attained velocity in physics, or not only in physics, in the universe so far. Still, no velocity beyond this level not yet discovered, not yet still noticed. So, this is the maximum attainable velocity. Therefore, c is equal to 3 into 10 to the power of 8 meter per second. Okay, such a speed indeed the electromagnetic waves are traveling. So, these are the examples of electromagnetic waves. As I told earlier, the main important properties of electromagnetic wave, EM waves. EM waves means electromagnetic waves. They carry no charge, and also they are not completely, they are all traveling with the velocity of light. Now, the Maxwell's proposed 4 important equations regarding electromagnetism. That is called, these equations are named after him, Maxwell's equation, because these equations are proposed by him, and he derived and formulated, and he established, and he gave the physical significance. Therefore, all the 4 equations derived by him generally called, named after him, Maxwell's equation in electromagnetics. The first equation, div means divergence. Shortly I am writing div. Div means divergence. The divergence of D is equal to rho. In mathematics, as you all know very well, the divergence can be written as del cross D. Okay? Del cross D is equal to rho, the alternate form of div D. Next, second equation of Maxwell's equation, divergence of B. That is, the divergence of B alternatively can be written as del cross B, that is equal to 0. The third equation, curl E is equal to minus of dou B by dou T. The curl E can be written as del cross dou B by dou T. I committed a mistake here. Del cross dou B by dou T is equal to minus of dou B by dou T. The term minus of dou B by dou T is missing here. I am very sorry. Therefore, curl E can be mathematically written as del cross dou B by dou T, which is equal to minus of dou B by dou T. The last and fourth equation, curl H, C is equal to J, capital J is equal to dou D by dou T. As you know, the curl H can be written as, alternatively written as del cross H is equal to J plus dou D by dou T. Let me introduce what are all the each and every individual terms found in the 4 equations. D, what is D? Is nothing but electric displacement vector. What is rho? Charge density. What is capital B? Represents magnetic induction. What is C? As I told earlier, it is electric field vector or electric field intensity. H, once again as told earlier, magnetic field vector or magnetic field intensity. J is called current density, and dou D by dou T is called displacement current. So, I have introduced all the important terms that are associated in the 4 equations. For example, div D, what is called D, rho is called, I have shown it. So, if you go through all the 4 equations, you come to know that these are all the each and every individual terms. Very important equation. In the examination, university examination point of view, they will ask you derive Maxwell's equations, very important questions. So, what are all the equations? And you have to derive each and every equations. Very important question, university examination point of view. The first equation, if we take divergence of D is equal to rho, is nothing but the differential form of Gauss law in electrostatics. The second, divergence of B is equal to 0, nothing but the differential form of Gauss law in magnetostatics. The third one, that is third equation, curl E is equal to minus of dou B by dou T, is nothing but the differential form of Faraday law of electromagnetic induction. E stands for electro, M stands for magnetic, electromagnetic induction. The last equation, curl H is equal to J plus dou D by dou T, is nothing but Maxwell's modification over Ampere's law. Because in this equation, Ampere made one suggestion, but the suggestion was not convinced by Maxwell. Therefore, Maxwell modified some changes over the Ampere equation and finally arrived the result curl H is equal to J plus dou D by dou T, that automatically it became the 4th equation of Maxwell. Okay. Now, physical significance of Maxwell equation. First, we have to derive all the equations in differential form. That is very important. As I introduced all the 4 equations, first we have to derive one by one, but all in differential form. Then the differential form of equation must be converted into the corresponding integral form. That is important. First we have to derive in terms of differential form of each and every equation. Then we have to convert each differential form of Maxwell's equation into integral form. Using the integral form, we may come to a conclusion. For example, from the integral form of the first equation, we come to a conclusion that the net outward flux of electric displacement vector through the surface enclosing a volume is always equal to the net charge contained within that volume. From the integral form of second equation, we know that the net outward flux of magnetic induction through any arbitrary closed surface is always equal to 0. From the third integral form of equation, we see that the electromotive force around a closed path or loop, whatever may be, is equal to the negative rate of change of magnetic flux linked with the path or loop. From the integral form of fourth equation, we see that the magnetomotive force, the third equation is electromotive force. The fourth equation is nothing but magnetomotive force. It means the third equation is concerned with the electric field. The fourth equation is concerned with magnetic field. Therefore, the magnetomotive force around a closed path is equal to conduction current, nothing but J. That is called conduction current density J plus displacement current dou d by dou t through any surface bounded by the path. So, this physical significance of Maxwell's equation is another important question. First, derivations of Maxwell's equation, that is separate question, that is essay type, may be asked in the part C. Similarly, the physical significance of Maxwell's equation in the another part C question. So, take care and prepare well, and separately first derivations of Maxwell's equation and next physical significance of Maxwell's equation. Now, 5 units are allotted in the electromagnetic theory. For example, unit 1 is completely devoted for electrostatics. Unit 2 completely devoted for magnetostatics. Unit 3 completely concentrated for the electromotive force. And unit 4 for electromagnetic waves. Complete last one, eventually the 5th unit, the applications of electromagnetic waves. First one, unit 1, electrostatics, nothing but charges at rest. What are the charges? We know there are 2 charges, positive charge and a negative charge. You know very well, as we studied in your earlier classes, in your undergraduate UG classes, you have studied well, I know well. Okay, positive charge, negative charge. Same charge means plus plus or minus minus. It's called like charges. If you place plus and plus, like charges. If you place minus and minus near together, like charges. Like charges always repel. Unlike charges always attract. If you place plus in adjacent to a minus is there, then there is a force of attraction. It means unlike charges attract. This is applicable not only charges, even magnetic field is also okay. Therefore, charges at rest, that is called electrostatics. The present unit deals with the electric charges at rest, the electric field, definition of electric field, the definition of potential, the electric field due to point charge, the electric potential due to point charge, similarly electric field due to distribution, electric due to point charge, potential due to point charge, and the potential due to distribution charges are discussed. Very important law, Gauss law. In this unit, the very important question is Gauss law in electrostatics and some application. Definitely a question as a university examination point of view, question may be asked regarding Gauss law with any few of its application, followed by the derivations of Poisson's equation, Laplace equation in one dimension and single dimension is also there. The concept of dielectric, very important, insulator and dielectric. Okay, conductor you know well, everything is conducted, conducts. Insulator, no, there is no free electron to conduct, therefore the insulator will not conduct. Dielectric is also conduct, not also conduct. Almost dielectrics are insulator, but there is a one thing very important. All insulators are dielectrics, almost, but all dielectrics are not perfect insulators, because even in dielectrics also there is some conductivity because of dielectric polarization. What is dielectric polarization? The displacement of charges. Positive charge move along the opposite side, the negative charge move on the opposite. When it will happen? When it is placed in the electric field. Therefore, there is a movement, migration of charges. Okay? Therefore, concept of dielectrics. Now, coming to the second unit, magnetostatics, that is magnetic field. All things are magnetic field. What is a magnetic field? As you know, I told you earlier, whenever a current carrying conductor, suppose a current is passing through a conductor, what will happen? A magnetic field is set up. Okay? So, the magnetic field is the site of the electric field, because what the conductor, through which the conductor, what is going on? Electric current is passing through the conductor. Because of the passing through the conductor, a magnetic field is set up surrounding the conductor. Magnetic field is associated with magnetic lines of force, magnetic induction, and Lorentz force and Fleming, all are related with the magnetic field. Then coming to the magnetic field, Faraday law of electromagnetic induction is discussed in this unit very nicely, because Faraday law of induction is, I know what is called the Faraday law, what is called induction, everything you know well. Next one is called the Biot-Savart law for determining the magnetic induction is given, very important law. University examination point of view, take care and prepare this question also, the answer for this question. And next one is the curl of magnetic induction and the divergence of magnetic induction is separately asked. Suppose in another question, derive an expression for curl of magnetic induction or divergence of magnetic induction. Coming to the magnetic properties, you know what are the magnetic properties? Diamagnetic, paramagnetic, ferromagnetic, all are discussed. But in your syllabus, ferromagnetic is given. The ferromagnetic theory can be explained, that is the properties of ferromagnetism can be explained with the help of domain theory. It's called Weiss theory. Weiss is the name of a scientist. So the domain theory of Weiss proposed by Weiss. Next one is called the Ampere law in magnetized material. It is also analyzed there. Coming to the third unit, Ohm's law, very basic. Whenever current is passing through a conductor, the potential difference developed at the ends of the conductor is directly proportional to the current. Vc directly proportional to I, where V is called potential difference developed. I is called strength of the current passing through the conductor. Therefore, Vc equal to R into I. R is introduced. What is R? The resistance of the conductor. Vc equal to R into I, the famous Ohm's law. The Ohm's law, next one is called resistivity. Resistivity closely associated with the Ohm's law and electromagnetic force. So these are very closely related each other. The next one is called induced EMF, with connected with self-inductance and mutual inductance, that is self-induction and mutual induction. And Maxwell's equations, propagation of EM waves, that is, as I already told, what are all Maxwell's equation, derivation of Maxwell's equation, the physical significance of Maxwell's equation. Coming to the third one, the propagation of plane EM waves. As far your syllabus is concerned, the propagation given, that is the propagation of EM wave taking place only two media. One is called free space. The another media chosen is called non-conducting isotropic dielectric media. So two media are given in your syllabus. Therefore, the Maxwell's EM, that is propagation of Maxwell's EM equations in free space, separate questions. Similarly, the propagation of Maxwell's wave equation in an isotropic non-conducting medium is another separate question. So that point consists of two important questions. So beware of that. Next one is called Poynting theorem. Poynting theorem is always associated with the flow of energy, that is electromagnetic energy. Simply I can say the theorem is always associated with the electromagnetic energy. Flow of electromagnetic energy is nothing but Poynting's theorem, and a Poynting vector is closely associated with it. Coming to the fourth unit, electromagnetic waves, energy and momentum, very important. What is the energy? Whenever a wave is being carried out, whenever there is any wave motion, both are carried out. Energy is also carried out and momentum is also carried out. So energy and momentum of EM waves we have to study separately. And waveguide. So many waveguides are available, but as far as your syllabus is concerned, only the rectangular waveguides are there. So first waveguide, and after studying the waveguide, you prepare your answer for rectangular waveguide. And coming to what are electromagnetic vector and scalar potentials? Very important questions. What are electromagnetic vector and scalar potential? And regarding the concept of gauge formation, transformation, very important two questions. One is called Coulomb gauge. Next one is called Lorentz gauge, separate question. Coulomb gauge is a separate question and Lorentz gauge is the separate question. So you prepare the answer for these two separately and take care. Any one of the questions may be repeatedly asked in the university examination. Coming to the application of electromagnetic wave, the fifth unit, Fresnel's amplitude equation. We are getting the Fresnel's amplitude equation in two cases. What are the two cases? We know electric field vector, isn't it? It is a E, capital E. When the electric field vector is perpendicular to the plane of incidence, we are getting one type of equations. The same electric field vector is also parallel to the plane of incidence, you are getting another set of equation. So this set of equation commonly called Fresnel's amplitude equation. But in the examination, you go through the question paper, whether they are asking electric field vector is perpendicular to the plane of incidence, or whether the question is asked electric field vector is parallel to the plane of incidence. First go through the question carefully and answer accordingly, very careful. And Brewster's law and degree of polarization, very important paragraph question. Define Brewster's law and define polarization. The last one is total internal reflection, very, very important theory. And you have that theory in terms of, you have to explain this theory in terms of electromagnetic theory, very important, be prepared it. I have suggested some books for study there for your easy understanding, for your easy reference, and these references will certainly will help you in preparing the answers for the I suggested question by me very in a easy manner and also to get through very high marks. Okay, thank you for patience hearing. Thank you. I wish you all the best.